When we think about AI, we usually picture something, well, kind of abstract, right? Like algorithms just floating around in the cloud. But here's the thing, that digital world, it's being powered by a very real, very physical revolution happening right here on the ground. We're talking about a massive global construction project. Think concrete, silicon, and steel on a scale we've literally never seen before. So let's get into it.
And look, this is way more than just another tech trend. The sheer amount of infrastructure we need to power artificial intelligence, well, it's kicking off a whole new industrial revolution. I mean, one that's going to physically reshape our world on a scale that's hard to even wrap your head around.
And hey, don't just take my word for it. NVIDIA's CEO, Jensen Huang, said it best at the World Economic Forum. He called it the largest infrastructure build-out in human history. I mean, wow. That one quote just perfectly frames what's going on. This massive physical machine hiding behind the AI curtain. So what does this whole build-out actually, look like on the ground? Okay, a pretty good way to break it all down is by looking at what we can call the 5 layers of the AI stack. So, right at the bottom, you've got energy. That energy powers the chips. And those chips, they live inside these huge cloud data centers. And it's in those data centers that the AI models are run, which then power all the applications we use every day. But here's the really crucial part. All 5 of these layers have to scale up together. They're totally dependent on each other. You can't have one without the others. All right, so let's see how this actually plays out in the real world. We're going to zoom in on one country that's doing something pretty incredible, India. They're strategically building out every single one of those layers, all at the same time. So to kick things off, just look at this number, $25 billion. That's what India's AM Group has committed to building a brand new AI compute hub. And this isn't just some idea on a whiteboard. We're talking about a massive injection of cash that's designed to put India firmly on the global AI map. What's really wild here is the sheer scale of it all. We're talking about a 1 gigawatt facility. To put that in perspective, that's enough power for a small city. And all of that is just to run about 500,000 high-performance chips. But what's really key is that it's going to be powered completely by carbon-free energy. So they're connecting that cloud layer directly to a sustainable energy source right from the very start. But of course, a giant compute hub is pretty useless if you don't have any chips to put in it. And this timeline, man, it just perfectly shows off India's ambition. Right now, they're mastering what we call mature chip nodes. These are the workhorse chips you find in electric vehicles and telecom gear, but they've got a super clear roadmap to get to the cutting edge stuff. We're talking 3 nanometer nodes by 2032. This is absolutely a long-term play for them to control their own tech destiny. So, how do you power all that ambition? Well, India realized pretty quickly that solar and wind just weren't going to cut it on their own. So they passed something called the Shakti Act, which basically opened up their nuclear energy sector to private investors. This was a really critical move to get the kind of massive, reliable, carbon-free power they need for their whole AI stack. And, this brings us to a much bigger, more fundamental global challenge. Because it turns out the most foundational and honestly, maybe the most surprising layer of this whole AI stack is just energy. The demand is so colossal, it's actually creating a global power problem, and it's one that's going to require some pretty radical solutions. I mean, it really comes down to the simplest question, right? Where does all the power come from? Because this question underpins the entire revolution. You can build all the amazing chips and data centers you want, but if you don't have a truly incredible amount of electricity to run them, well, they're nothing more than really, really expensive paperweights. And just to put this into perspective, this chart really says it all. A single generative AI query, something as simple as asking a chatbot to write a poem for you, it uses 10 times more electricity than a regular old Google search. Okay, now imagine that multiplied by billions of queries every single day. The energy demand just becomes astronomical. It's insane. So, what's the solution? How on earth do you generate that much reliable 24/7 carbon-free power? Well, for big tech, the answer is becoming really clear. And honestly, it might surprise you. They are betting billions on nuclear. And look, this is not just some theory. These are real massive deals happening as we speak. You've got Microsoft helping restart the infamous 3 Mile Island reactor. Amazon just inked a $1 billion deal for almost 2 gigawatts of nuclear power. Meta is trying to source even more than that. The big tech giants are literally becoming energy investors just to lock down the power they're going to need for the next decade of AI. Okay, so we've seen the huge physical build-out of data centers and power plants. But there's another race going on at the exact same time. It's a corporate race. And it's not just about acquiring technology, it's about acquiring speed.
And that brings us to another number that'll just make your jaw drop: $20 billion. That's the value of a deal NVIDIA recently put together with a smaller but crazy fast inference chip company called Grok. But it's how they did it that's the real story here. See, the most important thing to understand is that this wasn't your typical old school acquisition. Normally, that's a super slow process. You get bogged down with regulators. Instead, NVIDIA basically just bought access. They got their hands on Grok's most important intellectual property and their top engineering talent, all in a deal that gave them this massive competitive advantage, like almost overnight. So how do they pull that off? Well, this quote from Axios just sums it up perfectly. Everyone gets paid a lot. It's that simple. By setting up the deal to pay Grok's employees and their investors as if it were a full acquisition, they basically created a whole new playbook for how to buy speed in this AI arms race. Okay, so let's zoom back out for a second. We've got the energy, we've got the chips, we've got the massive data centers. But what is all of this for? What's the end game? Well, it's about moving AI off of our screens and into our physical world. It's all about building the robot brain. And that brings us to this really key concept: physical AI. So these aren't just models that can process text and images anymore. No, these are AIs that can actually perceive the real world, reason about what they're seeing, and then control a robot's body to go and perform complex tasks out in the world. And this isn't some far-off future stuff. It is happening right now. You can see it in that incredible new Atlas humanoid robot from Boston Dynamics, or in Hyundai's plan to roll out tens of thousands of robots in their factories. And at the same time, the tech giants, Google, NVIDIA, they're building the foundation models, things like Gemini and Griar00T, that are specifically designed to be the brains inside these new robot bodies. Okay, let's bring it all home. What you have to realize is that these are not a bunch of separate trends. The chips, the data centers, the power plants, the robots, they are all part of one single, giant, interconnected system. This is, quite simply, the world's new infrastructure. And make no mistake, this is a truly global thing. Just look at Europe. The AI data center market there alone is expected to explode to over $65 billion by 2031. And that same explosive growth is happening all over the world. We're watching a massive new economic sector get built from the ground up. So really, the next time you use an AI, just take a second and remember what's actually behind it. That smooth, seamless digital experience you're having, it's being powered by this huge physical and rapidly growing global network of concrete data centers, silicon chips, and yeah, increasingly, nuclear power plants. This whole build-out is creating absolutely enormous opportunities, and it's completely reshaping economies around the world. And it really just leaves us with one final and I think really crucial question. In this new industrial revolution, who's going to be the one to build the future?